looking back, looking forward, looking down, looking up, looking around. Come, join a journey of exploration to the distant past, to the frontiers of tomorrow, from the infinitely small to the infinitely large, the mysterious, the mundane. Come, let us travel to the horizons of knowledge. This program has been made possible thanks to a generous grant from the Swiss Agency for Development and Cooperation, the Vodafone Egypt Foundation, the OPEC Fund for International Development, and the Carnegie Corporation of New York. It is 476 AD. Rome has fallen. And for the next 10 centuries, the Dark Ages settle on Europe. The light of reason and of science would be maintained by the Muslim in their vast empires from Andalusia to the Indian subcontinent. Finally, Constantinople falls in 1453, and the Ottoman conquerors would found a magnificent Muslim empire that would shake the world. And yet, that same date, the fall of Constantinople, is usually taken to mark the end of the Middle Ages and the start of the Renaissance in Europe. The torch of learning was passing from the Muslim world to Europe. The European Renaissance was about a rediscovery of the past, the history of antiquity, the art of the Greeks, the law of the Romans, philosophy, literature, and soon it gave way to science. And both of these domains, Arabs and Muslims, had contributed much to protecting the past and in laying the foundations for the future takeoff of these sciences. But the Europeans frequently failed to recognize the enormous debt they owed to the Arabs and Muslims, but that does not diminish the reality of that debt. And so the Renaissance gave way a century later to the scientific revolution in Europe. For if the Renaissance was about the rediscovery of the past, the mythified Greek culture of old, the scientific revolution was about discovering the new. And for that, some rediscovered, some invented, but most adopted the same empiric method that Ibn al-Haytham had proposed a full 6 centuries before. European talent was to thrive when the stranglehold of the church was finally broken. Despite the wars and the instability and the emergence of the modern state as we know it, it was to be an amazing period of creativity and invention. Italy led Europe into the Renaissance and into the scientific revolution. Accademia dei Lincei, the Italian Academy of Science, was founded in 1603, more than half a century before the British and French academies founded in 1660 and 1666, respectively. architecture blossomed. The works of Brunelleschi and of Michelangelo come to mind. But the work of Andrea Palladio would set the definitive statements of the glorious classicism that was to bear his name. Vitruvius's 10 books on architecture, a classic of the Roman period that had been dedicated to Augustus, the first emperor. Remember, he was the one who had defeated Antony and Cleopatra. Vitruvius and his great work is brought back to life, amended, enlarged, and articulated anew by Palladio in his immortal 4 books on architecture, which, with his works and villas in northern Italy, made him the most influential architect in Western history. Medicine emerges from the darkness of the European Middle Ages, with the anatomical studies of Leonardo da Vinci, and then the enormously influential work by Andreas Vesalius. His 1543 treatise on anatomy, De Humani Corporis Fabrica Libri Septem, on the fabric of the human body in 7 books, generally known as the Fabrica, would become the most influential medical work of the Renaissance for several centuries after. William Harvey would discover the circulation of the blood in 1628. He did not seem to know about the work of Ibn Nafis, who had already described the circulation of the blood more than 300 years before in the mid-13th century. But let us go back to the early scientific revolution. Francis Bacon in England, René Descartes in France, and Galileo in Italy are the key actors who established in the West the modern empirical scientific method. What was that all about? The single momentous item that truly marks the flowering of the scientific revolution in its own right was Nicholas Copernicus's treatise that placed the sun and not the earth at the center of the universe. It is true that he knew of the work of the Maragha school of astronomers and particularly of the mathematical work of Ibn al-Shatir.
ابن الشاطر لم يقترح ولم يفكر إطلاقا بأن هناك إمكانية أخرى تسمى مركزية الشمس، ولكن قدم على طبق من فضة هذا العمل المتكامل لكل هذه الأشكال الهندسية، جمعها بشكل موحد ليصبح بسهولة أن يأخذ واحد مثل كوبرنيك يثبت الشمس ويحرك الأرض وما حولها بالمركزية الشمسية.
Nevertheless, whatever his debt to others, the idea of putting the sun at the center of the universe, a revival of the heliocentric theory of Aristarchus in the old library of Alexandria, is truly to Copernicus's everlasting credit. This, however, contravened church doctrine, and Copernicus published his treatise on his deathbed, and it was left to Galileo Galilei, the greatest scientist of his time, to become his defender. The church objected, and Galileo was to be indicted, and he was tried in 1633, and he was forced to recant and spent the last 8 years of his life in forced residence. But who remembers those who tried Galileo? Who respects their views today? Over the long run, it was not naked power that triumphed. It was the ideas and methods of Galileo that emerged victorious. And the views of Copernicus became established as the foundation of the new astronomy and the new cosmology. Science triumphed in this first of many confrontations with the established institutions of religious doctrine that wanted to govern scientific thinking and limit the knowledge generated by the scientific enterprise. Isaac Newton was a true genius. The young recluse redefined the laws of motion, systematized optics, invented calculus, worked out the mathematics of celestial mechanics, became a professor at Cambridge, and a member of the Royal Society, all before reaching the age of 30. Using his 3 laws of motion and the law of gravity, Newton was able to explain the motion of the Earth, the Moon, and the planets around the Sun, and showed that these same laws would explain the fall of an apple from a tree and the tides of the seas. He used mathematics to decisively settle all the pending questions of his time, thereby making mathematics the central tool, if not the absolute language of science. Before Newton, the majority of humanity, even the educated elite, either did not believe that there were laws that governed the universe, or that if such laws existed, they were beyond the ken of humans to discover or understand. After Newton, gradually all educated people came to believe that there are laws that govern the universe, and if we do not yet know them, then it is just a matter of time till we discover these laws. An amazing turning point in the history of human thought. When told by admirers that he had seen that which no one else had seen, he replied, honoring those that had worked before him, and said, "If I have seen farther than most, it is because I have stood on the shoulders of giants." A contemporary giant, the great Stephen Hawking, in fact, reissued the masterworks of physics in this book called On the Shoulders of Giants. The 17th century saw an enormous explosion in mathematics. Old problems were solved, new doors were opened, from the invention of logarithms to the invention of calculus, and the problems of chance and probability. Blaise Pascal, a sickly child who at age 16 had produced a treatise on conic sections, that's a family of curve that includes the circle and the ellipse. It was the greatest advance on the subject since Apollonius of Perga tackled it in the ancient library of Alexandria 16 centuries before. In fact, some, including the great Descartes, could not believe that such a child could produce such an amazingly profound work. Pascal also invented the first functional calculating machine using the decimal system. Let's take a look at that remarkable machine, still known as the Pascaline. Pascal was also challenged by a friend of his to use his talent to help solve the problems of gambling. Were there rules that guided games of chance, was the question. Pascal took up the challenge, and with his compatriot Pierre de Fermat would invent the science of statistical probabilities. The history of mathematics is filled with other fascinating characters: Euler, Bernoulli, Galois, Hamilton, and Gauss, to name but a few. Let's stop briefly for the story of Gauss, possibly the greatest mathematician of his era and maybe of all the recent period. Gauss was a prodigy. At age 2, he corrected his uncle's addition. As a young child in school, the teacher gave the children the task of adding all the numbers from 1 to 100. Gauss instantly wrote out the correct answer, 5,050. For us, more ordinary people, let us follow step by step what his lightning intellect was able to complete in seconds. Note that the numbers from 1 to 100 can be grouped in pairs, the first and last, and working your way inward. You will note that 1 plus 100 equal 101. 2 plus 99 equal 101. 3 plus 98 equal 101. All the way to 50 plus 51 equal 101. And since there are 50 pairs in 100, therefore the total is 101 multiplied by 50 equals 5050. That, my friends, was the genius of Gauss at 5 or 6 years old. No wonder that as a young man, his doctoral thesis was to become the fundamental theorem of algebra. A few distinguished women must be mentioned. They fought against enormous odds to establish themselves, so prejudiced was society against them. The amazing Hildegard von Bingen, the first musical composer known by name, was a 12th century Christian mystic, German Benedictine abbess, visionary and polymath. She founded monasteries, wrote theological, botanical and medicinal texts, as well as letters, liturgical songs, poems, and the first surviving morality play. All of this while supervising brilliant miniature illustrations. One of her works as a composer, the Ordo Virtutum, is an early example of liturgical drama. Italy supported women academics more than other parts of Europe. Thus, we have a proud tradition from Trotula, a nun and medical expert in 11th century Salerno, to mathematician Maria Agnesi and physicist Laura Bassi in the 18th century. Émilie du Châtelet, the love of Voltaire's life, was an accomplished scientist who organized at her chateau at Cirey a veritable think tank. Yet society frowned upon her activities. But even when the law was not prohibiting them from practicing science and medicine, women were still expected to attend to their female societal roles. They were still expected to raise the family as they do their science, and some have done it magnificently. Witness Laura Bassi in 18th century Italy, Europe's first woman physics professor who also raised 12 children. Witness Marie Curie, first woman professor at the Sorbonne and the first female Nobel laureate, widowed mother who wins a second Nobel Prize for herself and also brings up her daughter, Irene, to become a scientist, and the daughter also wins a Nobel Prize. Remember Pascal's calculating machine? Well, it would be quite a while before we got a real computer. But in the 19th century, Charles Babbage in England would invent his difference engine, the first programmable computer. Here it is. But the person who would explain with lucid prose and exceptional ability how it worked, and the person who worked out the algorithms and who became thus the world's first computer programmer, was a woman, Ada Lovelace. She was the daughter of the famous poet Lord Byron. Yet such was the prejudice in those years against a woman in science that she could not sign her scientific papers in her own name. She used her initials only. Actually, the formation of science as we got to know it in the 20th century can be traced largely to developments in the 17th to the 19th century. Prior to that time, scientists were known as natural philosophers. In other words, philosophers who are primarily concerned with nature. In fact, the name scientist would be coined by the British polymath Whewell only in 1840. As physics developed, so would biology and chemistry. How each became a recognized science will be treated in separate episodes. Along with advances in science, technology had made European nations rich and prosperous. For technology is the application of scientific principles to utilitarian issues and needs. The Industrial Revolution and the new technology also powered armies, navies, and the equipment of war. science and technology made the European nations the preeminent powers on the planet. They colonized and dominated the world. The new century was to see the rise of science, the victory of the scientific method, and an unparalleled creativity in the West, which led to the enormous explosion of new technologies in the age of science. More advances were to be achieved in one century than in all of the previous eras of recorded history combined. Meanwhile, in the 19th and 20th centuries, we created the edifice that we are working with at this exciting moment in the 21st century. But what of Egypt? In the 19th century, Egypt was to wake from its centuries of profound slumber and to try to link with the best of science in the modern world. Who did what and what was done is an exciting story of many interesting personalities. But that is a story for another day. I am Ismail Sirajuddin, and I thank you for having joined me in this episode of Horizons.